So, two main types of probability we're going to talk about. The first is classical method, or the what used to be called the theoretical method. And the classical method is how you think about computing probabilities for rolling a die or flipping a coin. We are looking at the total number of ways that our event could happen over the total possible number of outcomes. So let's take a look at example one here. We're flipping a fair coin. What's the probability that you flip the coin and it lands on heads? We are going to start with our notation. Probability of heads, don't have to write everything out. When we flip a coin, and here's my sample space, heads and tails, I know there are two different things that could happen. There is one way to get ahead. So the probability of getting ahead when we flip a coin is 1/2. You do not need to reduce the fractions. A lot of times we're going to need to add them together. Well, we want to make sure we have a common denominator anyway, so we're going to leave it that way. Example 2, you're playing a game. You have a single die that you roll to start. You start playing the game, and in order to move your first piece, you must roll a 6. So consider first what our sample space is for a roll of a die. I got 1, 2, 3, 4, 5, and 6. If I want the probability, I roll a 6. There is only one way that can happen. There's my 6 out of the 6 possibilities on the die. Oops, again, let's move this down one. So we roll a 6 to start. And now we're rolling 2 die. We're in jail and need to roll a double to get out. So I am going to fill in this table about all the possible rolls of a die, and I'm going to be very specific about using 2 different colors. Because a lot of times when we talk about things that can happen on the roll of a die or 2 dice, it gets confusing when we consider that there are 2 possibilities here. It makes a little more sense if I color code them. Also helps when we are creating data like this or outcomes that we organize so we can see what we got going on. So here's a roll: 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, and 6, 1. I got 1, 2, 2, 2. I can't talk and write at the same time, so I'm just going to fill this in. First thing we want is the probability that we roll doubles. If we organize our table nicely, we can usually find the information we want fairly quickly. So the probability here of doubles, I have created a 6 by 6 table, so I know there are 36 outcomes. I go right down that diagonal. I have got 1, 2, 3, 4, 5, 6 ways to roll a double. I'm going to leave it like that. We have gotten out of jail, and now we need to roll an 8. Find the probability that you land roll. We're not land rolling, we're just rolling. We roll 8 and land on the space that we want. So where are our 8s? Start with the easy one: 4 and 4, 3 and 5, 2 and 6. Now we've got a red 3 and a green 5. When we look at it this way with the two different colors, it makes sense that red 3 and green 5 is different than red 5 and green 3. And here's our last one, that red 6 with green 2. Probability that we roll an 8 are those 5 highlighted in orange out of our 36 possibilities total.